Algebra 2, Lesson 120, Age Word Problems. The key to age word problems is understanding the past, the present, and the future, and how we can logically express this in math. So if we solve age word problems and we always solve them from the standpoint of we are living in the present, that gives us a good baseline on how we can express the past and the future. So if we do all of our problems written in the form of the present, then the past would just be whatever number we have minus some numbers. So the present minus a value would get us in the past. If we want to do the future, we'd do the present plus some numbers. That would give us the future. So if we write all of our problems in terms of the present, we won't have any trouble. So let's go with the first example. They tell me a man is 13 times as old as his son. In 10 years, he will be 3 times as old as his son will be. How old are they now? All right, so this is the present. The man is 13 times as old as his son. Let's go ahead and write that as an equation. I've got the age of the man. That's equal to the age of the son, but that's not true because the son is younger. I'm going to put a 13 times right there. Great. I've got my first equation written in terms of the present. Now, how in the world am I going to do in 10 years? Well, in 10 years, the man will now be man plus 10. Right? So instead of writing man, I'm going to put man plus 10. Now they say in 10 years, he will be 3 times as old as his son will be. So man plus 10 will now be son plus 10, but that's not equal. It'll be 3 times as old instead of 13. All right, so now this is my new equation. So now I'm going to solve by using some substitution, but before I do that, I'm going to simplify this equation. Right? I'm going to rewrite with distributive property. So now I've got 3 times the son plus 30 is going to equal just n plus 10. That parenthesis can go away. And now let's do some substitution. Instead of writing m, I can write 13s. So over here, I'm going to put 13s plus 10 is equal to 3s plus 30, right? Kapow, substituted. Now I've only got one unknown, and I can solve by getting all my getting all my variables on the other side. We'll move to the left. We'll subtract 10. Right? That cancels. I'll also subtract 3s. That cancels. So 13 minus 3s is 10s. 30 minus 10 is 20. Last step, if I divide by 10, I get that the son is only 2 years old right now. Great, so if the son is 2 years old and his dad is 13 times that, then 13 times 2 gives the age of the dad, so that means the man is 26, right? And that's it. That's how I got the right answer. Now that one's pretty simple, right? It's all addition, subtraction. They're going to give you the same type of problems, but they're going to use some fractions. Okay. So let's see if we can find a difficult one. We'll go into the past and we'll use some fractions. Okay. So we got example 120.3. They tell me 30 years ago Barbie was 1 year older than twice Mary's age then. Oh man. Okay. 20 years ago Mary was 4/5 as old as Barbie was then. How old is each girl now? Now remember, it's very important. I said we got to write all of ours in terms of the present. So 30 years ago, I'm not just going to start with Barbie 30 years ago. 30 years ago is going to be Barbie minus 30, right? And then 20 years ago, it's going to be everyone minus 20. So let's start with this first equation. 30 years ago, Barbie was 1 year older than twice Mary's age. All right, let's break this down slowly. 30 years ago, so 30 years ago, Barbie minus 30, and it says that she was, that's equal sign, 1 year older than twice Mary's age. So twice of Mary's age 30 years ago, and 1 year older, so plus 1. So 30 years ago, Barbie was twice Mary's age, 1 year older than twice Mary's age. Cool, I've got my first equation. Now let's see here. Then they say 20 years ago, Mary was 4/5 as old as Barbie was then, 20 years ago. Okay, so 20 years ago, we've got Mary, so Mary minus 20. And it says she was 4/5 as old as Barbie was then. So that's going to be Barbie minus 20. Where in the world do I get the 4/5 of Barbie's age? Well, if you remember, the fractional part of a number times number is the answer. So if it's 4/5 of Barbie's age, we're going to multiply 4/5 times Barbie. Okay, that's how that works. Now that I've got my two equations, I'm going to simplify them as much as I can. I'm going to do that with the purple marker. Let's see here. This equation, we'll rewrite this. The left side, b minus 30, is going to stay the same. So no changes there. Then I draw my equal sign. The right side of the equation, I'm going to use some distributive property. So now I've got, well, this will be 2m minus 60 plus 1. Minus 60 plus 1, that's going to be minus 59. So I've got 2m minus 59. Great, I've rewritten the top equation. Bottom equation, m minus 20, that's not going to change either. The right side, 4/5 times b minus 20. So that's going to give me 4/5 b, and then minus 20. 4/5 times negative 20. That'll cancel. That's 1 and 4, so negative 16. Cool. Got a nice whole number there. That was great. Now, what am I going to do to solve? Well, right now it can be a little difficult to see what's going to happen. So what we can remember is this is a system of equations with two unknowns, right? Normally when we do these problems, or, the way we've been doing it the whole school year, they've looked like this, right? We've had problems that look like this. It was always, x, y, and then whole number, right? And we'd substitute, eliminate to solve. This one's not written in that order. So how about I do that? Let's write it in an order. Let's get the b number first, the m number next, and then let's make the whole numbers, the constants, on the right side. So I'm going to rewrite again one more time just to make sure that this is to my liking. So for the top equation, I'm going to add 30 to each side. I'm going to subtract 2m from each side. When I do that, what I end up getting is I have b minus 2m on the left side, and then negative 59 plus 30 is going to be negative 29. So now I've got b minus 2m equals negative 29. That's a lot easier to read. Let's do the same thing with the bottom equation. We'll add 20 to each side, then we'll 4/5 b minus 4/5 b. That fraction is not working out for us anymore. Negative 4/5 b, right? And I'm going to make sure the b is in the front. So I'm going to have negative 4/5 b plus m equals, let's see here, 20 minus 16, 4. Right, so now I've got two systems of equation. This looks a lot better, but that fraction's bugging me. I could try to get rid of it now, or I could eliminate the m's and get rid of it later. There's a couple ways I can do this. I'm a big fan of not having the fraction in there, so I'm going to scale this entire bottom equation by multiplying by 5. So if I multiply everything by 5, what it turns into, it's going to be negative 4b plus 5m equals 20. Right, so now I've got two equations, okay? And I can substitute or eliminate now, right? So there's a lot of work that goes into writing this equation properly, but once you get it properly, it's easy to see how to solve. So that's the main logical work on this, is when they put some fractions in the h problems, we got to do quite a bit of rewriting before we can get to the point where we're ready to solve. So let's see here. If I scale this top equation by 4, I'll have positive 4, negative 4, and I can use elimination. So let's do that. If I make that 4b, that would become negative 8m. Negative 29 times 4. Negative 116. So now I've got 4b minus 8m equals negative 116, and I can finally eliminate. That gives me negative 3m, and that gives me negative 96. So negative 3m equals negative 96. I think I've got the answer in my head. That should be 32. Let's just find out. Negative 96 divided by negative 3, 32. Okay, great. M equals positive 32. Great. So now Mary's age at present is 32. So Mary at present is equal to 32. And I lost my practice problem. Hang in there. We're almost there. We're almost done. We're almost done. Okay, they want to know how old each girl is now. That's perfect. I don't have to do any more time traveling. All right, so Mary's 32. I've got one of them. If Mary's 32, can I figure out how old Barbara is? Well, let's just go back into one of these equations, preferably one of these two bottom ones over here, because those are the simplest. So if m is 32, let's see here. Let's solve. Oh, you know what? I'm going to use this red one, because this red one was pretty simple. It was just b minus 2m equals 29. So if I've got b minus 2 times 32 equals negative 29, that's going to become negative 64, right? Add 64 to each side. So then b is going to equal 64 minus 29, which is, oh, my brain's not working right now, 35. So 35, Barbara is 35, and that is correct. All right, so a lot of good thinking, a lot of good algebra skills to see here. Starting from these problems and moving down. So this is a really good test of your algebra skills. If you guys have any questions, let me know on the school website, and I will see you in class.